فيهم مساكين فتاهم الصباح والإخلاص بين هذا بس هو اللي فيك اكيد ما بعد هو ما كان يبي يشوف من اللي يسجل بيتي او من اللي بيمسك كيك ما بعرف ما في كيك او شلون انا يجي بس لكن تهم
Okay, gentlemen, I want you to turn off your mobiles and keep your mobiles in your pockets throughout the class. Now I'm going to start the first question of Stat 310, Term 211. Now, this is how the details of the questions will be given to you. Now, read these details. It says that you consider a simple linear regression model with one predictor, yi equals beta naught plus beta 1 xi plus epsilon, where beta naught and beta 1 are the unknown parameters and xi's are the fixed variables. Now, the OLS estimates for beta naught and beta 1, they are given as this. Starting with beta naught equals this, mathematically prove that variance of beta naught hat is derive the variance of beta naught hat. So this is what is required. Now here you can see I have given as a note that you can use summation c equals 0, summation cx equals 1, and summation c square equals 1 over sxx, which means you do not need to derive it, especially for this one, where c is also defined to be x minus x bar over sxx. So the solution of this one is very straightforward. What is it? You just need to prove that beta naught, is it beta naught? Yes, you just need to prove that beta naught hat is nothing but summation 1 over n plus ci xi times yi. You need to prove this, which is straightforward. We did that in the class. And then you just need to apply the variance expression. Once you apply the variance expression, this, and this, I think 2 out of these 3 will come somewhere in the derivation. And you should be able to do it very easily. Any question from this problem 1? This is straight away from the lecture, no problem. Yes. You have to. This is a very important point. Anything that is not given as a note, you need to prove it. I was trying to, by the way, do you guys know that we are unable to send you the emails? Anyone who's sending emails, I'm replying, but it bounces back. I don't know, for some reasons, the server is not accepting, for any student, the server is not accepting the emails. One of the student I do receive, but when I reply, it doesn't go. One of the students, he sent me an email that while proving E bar equals 0, can I do it like starting with summation E equals 0, because we proved this thing in the class, summation E equals 0. So just divide both sides by n, and you get what? E bar equals 0 straight away. Yes, you can, but if you do that, you prove this, that summation E is 0. Before using it, you prove it if it is not given as a note. If it is given as a note, no need to prove it. Yes. Of course, anything that is not given as a note, you prove it. Even if you have confusion in the exam, ask me if I need to prove it or not. During the exam, if you have a confusion whether I should prove this or not, some of the things are very straightforward. 2 + 2 = 4, you don't need to prove it. So if you are confused if it is straightforward or not, ask me. During the exam, ask me. If I'm not there, ask the proctor, he will call me. Anything, any confusion or anything from question number 1 before I move on to question 2? Yeah. If I ask the same thing for beta 1, you need to prove that beta 1 had a summation Ci,yi. And then you can use these properties, summation C, summation Cx, to prove to the variance. Yes. I can solve it, but it will just be a wastage of time. I can refer you to the page number here. Yeah, I can refer you to the page number. It's here. Week 2, the expectation, after the expectation, we proved here. So you can go and look at this one. Take a picture of this one. Yes. From the moment I stopped in the exam, this is what you need to proceed and end up with this result at the bottom. This is required. Okay, let us move on to question number 2. Question number 2 is from chapter number 2. This says that for a multiple linear regression model, you have y = x beta plus epsilon. The model is given. Derive the ordinary least square estimate of beta. This is straightforward from the notes. I will tell you again where it is proved and where you start and where you end. For this question number 2, you go to week number 5, I think. 6. No, 5. Here it is. You need to start with this model. Okay, then you need to define your objective function to be minimizing summation epsilon I square. Then you need to prove that summation epsilon I square is equivalent to epsilon prime epsilon. Then you minimize this function, differentiate it, and before differentiating, you simplify it. We're simplifying it before differentiating. Differentiate it, you get these equations. Many of you found the answer for this one from what's that matrix book, cookbook or what? Cookbook. One of the equations is equation 69. You use it. The other one is 85. The first one is coming from equation 69. The second one is coming from equation 85. So you can just refer to it. In exam, you don't need to prove this specific result. This is not a content of Stat 310. This is a content of basic math course. And you come up with beta hat khalas. So this is the solution of question number 2 that we are expecting from you. Any question? This one? It was an assignment. Did I post it? What am I doing? Oh. Was it?
This was start 510, Doctor.
I opened the R language for. No, here it is. Yes, you were right. It was week 6. Here it is, assignment 6. Now you feel good? No, that 9 was in week number 6. Yeah.
We must now reach maximum.
Yeah, they have reached. So here it is, number 6 for you. Again, you don't, if this question comes in exam, you don't need to prove this. This is prerequisite knowledge for this course. So here we did this one, and you're supposed to reach this point. That's it. Beta hat equals X transpose X whole inverse X transpose Y. You're supposed to reach this point. Any question? Where is the exam? I uploaded it there. Okay. Let us move on. Question number 2B. Show that beta hat is unbiased for beta. Again, a copy paste question from the notes. I'll take you to the notes. Maybe the immediately next lecture.
Y bar minus X bar. Then I find the expected value.
No, this is for matrices. Gentlemen, this is the solution for 2B. You start with beta hat because you have already derived this beta hat in part A. If there is a student who is unable to do this in part A, he doesn't know the answer. In part B, you ask me that I want to get beta hat, the expression for beta hat, to do part B. I don't want to do part A. I don't know how to do it. I don't know the expression for beta hat. Tell me beta hat for part B. I will cancel your part A and tell you the starting point of B. Like I'll give you this beta hat. And from there, you need to do what? Apply the expectation. Use all the supplementary concepts that we showed in the class and get to this point, the 4th step. That's it. These are the 4 steps you are required. Again? If there is a question for which part B is relying on part A, and you know how to do part B, but you don't know the answer to part A, and you want to let go of the grade of part A and want to gain only for part B, tell me. I will put a cross on the part A for your exam paper, give you 0 right in the exam there, and tell you the starting point of part B. It's better than losing for both of them.
How about if you give us the final answer and you ask us the question to show us this would be.
Don't tell me what to do.
No, I'm not
I will tell you what to do.
Guys, you give us this, so
I will
we
not
can-
give you the answer. I showed you how the questions will come. You need to derive. For this question, yes, I gave you that expected value of beta hat is beta. For the first question, I did not give you the right side, just the variance of beta not hat or something, 1 hat. Yes. Yes, what's the question? No question. Let's any problem from that question? Okay, let us move on to if there is a part C of this question. Yes, there is a part C. What is that? Variance covariance. In continuation, the immediately next derivation is the variance covariance. So you need to go through this one. Variance covariance, which is sigma squared times X transpose X whole inverse. Again, I did not give the result the right side for this question. So you're supposed to reach that bottom result. Any question? No question? Let us move on to next question. This is a critical question, a very difficult question to start with, not to end with. You will see we have used almost everything in the derivation. We have done that, but it's tough to start with. Read the question. The question says you consider a simple linear regression model where beta naught, beta 1 are unknowns, x's are fixed, the OLS estimators are given as this, the formulas of SXY and SXX are provided, mathematically derive the expected value of beta naught hat multiplied by beta 1 hat. What are fixed? No, B naught and B1 are fixed, but beta naught hat and beta 1 hat are not fixed. This is what you need to derive, right? They are not independent. No, you cannot assume. Can I assume that you get 0 in exam? I cannot. I cannot. You cannot just assume anything that they are independent. Now, there is a hint given in the question because this is a tough question to start with. What is the hint? The covariance between xy is equal to the expected value of xy minus expected value of x, expected value of y. So you use this hint to solve the middle part, which is expected value of xy, which will be equal to covariance of the two plus expected value of this times expected value of this. So you start with using this hint. You start with this covariance of beta naught hat comma beta 1 hat. This is nothing but the expected value of beta naught hat with beta 1 hat minus expected value of beta naught hat times expected value of beta 1 hat. Now, in one of the assignments, we proved this one to be minus x bar times sigma square over SXX, I think.
Yes.
In one of the assignments, we proved this one, the left side. You need to do all of it, the assignment. This is equal to expected value of beta naught hat, beta 1 hat, and then look at the note. What does the note say? You can use the unbiasedness of beta naught hat and beta 1 hat without proving it. What does that mean? You can use expected value of beta naught hat to be beta naught, and you can use expected value of beta 1 hat to be beta 1 without proving. So I'm using that to be beta naught times beta 1, and you're done. Just take this thing to the left side and you're done. But prove this one. The left side, all the work is basically the left side. All the work is left side. Yes, to prove that covariance of beta naught hat and beta 1 hat equals this, I will show you where did we prove it. The exam? 2 hours maybe? Yeah.
For the 2 sections.
Yeah. I just showed you 3 questions. There are 3 questions in exam, and each of the question was no more than 4 steps. Yeah, this is the last question of exam. Mathematical exam, this was the last question. Then comes the computational.
Like 1 hour.
It will be ideally 1 hour and 1 hour, but you can extend the first one. But keep in mind, if you extend the first one, you will be taking time out of your second exam. The end point for both of them will be same. If you finish early, you take the next one early. You'll have more time for the second one. This will not be the case most of the times. Most of the times, the students will give up early. And they will say, we don't want to look at the mathematical exam anymore. Give us the other one. Yes. The exam 101, 202 in building 5. Some students in 101, some students in 202. I will make an announcement.
They're both labs, right?
They are both labs. You don't need to, but you're recommended to. Through Blackboards. No, through Blackboard, I will make a column, a new column, grade center. I'll make a new column which will tell you about the room number. It will either be 101 or 202. You can go to the location and see which one is it.
How many questions in the second part?
I will first let me find the solution of that assignment. Where is that assignment? Can anyone tell us? Week which? 4. Here it is. The covariance here. Straight away it popped. This is the property that we are talking about. Covariance of beta naught hat and beta 1 hat comes out to be minus x bar times sigma square over sxx. You need to do these 1, 2, 3, 4, 5 steps.
Why?
Yes.
The minus first virus.
Yeah, covariance of y bar with beta 1 hat. Again, you need to prove it. Where is it? That is the assignment, yes.
That you mark,
Mm-hmm.
you have to do the same thing.
Yeah. I marked the blue to explain that that's how you open the covariance expression.
Very wrong question. You have to prove that again. It's equal to 0.
If you are in practice, it doesn't take more than 5 minutes. If you are in practice, it doesn't take more than 5 minutes.
So looking at the questions, if we like master the notes and all the groups, we should be fine. That's it, right?
Yes. Let's hope. Yes.
The distribution of the two parts of the exam are equally likely.
No. No, they're not 50-50. Like, look, for part A, the score is 10 plus 8 plus 7. What is it?
I mean, two parts between the mathematical part and the computer part.
Yes, that's what I'm telling you. The overall weight of the first one is what? 10 plus 8 plus 7 is what? 25. The second one is what? Also, luckily it is 25, but it may not be. It will be similar. The points I will give, but it may not be the same. You may have a bonus, you may not have a bonus. Look at the bonus question, by the way. Where is it? Yeah, the bonus question is the assignment. You need to prove that MSE is unbiased for sigma square. That's the bonus question. I haven't proved it in the class, I know. Same question as bonus? Khalas, I'll give you same question as a bonus in multivariate regression. Chapter 3. Matrices. For multiple regression, prove that MSE, which is SSE over n minus k minus 1, is unbiased for sigma square. I can if you want. If you ask me now, even I cannot prove it. I need to look at 3 books to get to the proof. Okay, this is the mathematical part. Any problem, any confusion? Last question. The bonus is assignment. It's one of the assignments. Assignment what?
It's not assignment.
It's what?
No, it's not.
It's what?
You didn't give it to us.
I didn't?
No.
This was the bonus question, and I think it was not assignment in last semester also. It just came into my mind and I gave it. For this one? No, I will not. I can. For simple, I can now, but I will not. Go and find it yourself.
We have the same again.
Bonus means bonus. No, you will not have the same. Of course, you will not have the same. You may have the same.
The same question, we may not be able to solve it.
That is true. I give you exact same exam, you may not be able to solve it.
Can you just give us a hint?
For this one,
Yes.
no hint. No hint, nothing. Okay, do you want me to open another mathematical exam or the same computational for this one? Let's open the computational part of this one. For the computational, we will just scroll through. We will not do anything. I said we'll just scroll through. Look here. What do you mean by which table? This is 211, 1 year ago. Now this question says that you have to download the data set from the Blackboard, and then when you download the data set, it will give you the code number for the data set. Write that code number here. Be careful with this one. There will be 10 to 12 codes for data sets, different data sets. All of them will have different answers. So make sure your code number is right. Then it says the description of the variable. An accountant for a large store would like to develop a model to predict the amount of time it takes to process the invoices. Data are collected from past 26 days on number of invoices and the completion time. What is Y? What is X? Completion time is dependent upon number of invoices. So completion time is Y. Number of invoices is X. Estimate the covariance between the two of them, SXY over N minus 1. What do we need? Covariance. Covariance is what? Summation X minus X bar into Y minus Y bar over N minus 1. Let me open the formula sheet for you also to show you that these formulas will be given. For the computational section. Look here. The formula for SXY is given here. So the covariance is nothing but this SXY over N minus 1. If I ask you for the variance of X is this thing over N minus 1. If I ask you for variance of Y is this thing divided by N minus 1. So you just need to divide by N minus 1. I think the whole formula is not given. With N minus 1, it's not given. You just need to divide it by N minus 1.
This will not be given.
No, this will not give it will not be there. Okay, the question says, number 1, you find the covariance. Number 2, you interpret the covariance. So how do we interpret the covariance? The covariance only tells us about the direction of the relationship. It doesn't tell us whether the relationship is strong or weak. To get to know whether it is strong or weak, you need to convert it to correlation by dividing by the variances, the square root of variances. So before dividing by the square root of variances, the raw value of covariance will tell you the direction of the relationship, whether it is negative or positive. That's it. Nothing more than that. Once you divide it by the square root of variance of X into variance of Y, then you standardize it to a scale of -1 and 1. Then you can comment if it is strong or not. If it is close to +1, it is strong. Close to -1, again strong. But without standardizing it with respect to the square root of variances, you cannot comment on the strength. You can only comment on the direction of the relationship. Yes, A. We're talking about A only. So you will just find the covariance. In Excel, by the way, there is a direct command of covariance also. I think COVAR, covariance.
Should just put an X and give you only number.
Yes, here you need to put the number 1 point something, full stop, second line. What does this 1 point something mean? That's it. No proof, no formula, nothing. Part B, fit the two models. It says fit the two model, one with intercept, second without intercept. Question says which one has the smaller SSE? Why? So you have to put the SSE of model 1 there, just the value. SSE of the model 2 there, just the value. And you have to tell which one is smaller and give the reason why the one that has smaller SSE, why that one has smaller SSE. Which one will have smaller? With intercept, without intercept? Without intercept or with intercept? With intercept will have a smaller error. With intercept will have a smaller error. Think of the reason. No, there is no partial point for these one. You get the right number, you get the full credit. You get the wrong number, you get 0 credit. And be careful, I will not look into your Excel sheet. I will not ask for your Excel sheet. Whatever will come out on this paper will be graded. Yes. Why? Think of the reason why this one is smaller. You know the reason, you are unable to formalize it in words. You know it.
Because this has an
Okay, for model number 1, what % of the variation in Y is not explained by X? The amount of unexplained variation. What % of the variation is not explained? SSE over SST. Or you can find R square and take 1 minus R square. Any way you like. Again, only the credit is for the final number. For model 1, test the hypothesis that the completion time increases by more than 1 hour due to an increase of 1 unit in the number of invoices. That is, you have to test this statement, beta 1 greater than 0. What will be H0, H1? The given thing is H0 or H1? This is H1. Define H0 yourself, then write H0, H1, write the value of the test statistic here. Don't write the formula. Just write the final value of your T statistic. Then write the p-value. Here you are forced to use the p-value approach. If you use the critical value approach, you will lose the point for this p-value. You will get the points for T statistic. You will get the points for the decision and conclusion, but you will lose the points for the p-value. So here you are forced to use the p-value approach. Yes. I don't know. No. For this one, yeah. For this exam, I can give you the solution. For this exam, I can give you the solution. I will share the data set with a specific code. Let's say I will share the code 1 data set and give the answers for that code 1, because there are multiple codes here. For model number 1, also there were some students who made this mistake. They did all of it for model number 2. Be careful for that one also. All the remaining questions except for part A, they are all about model number 1, which means with intercept model. For model number 1, construct a 98% confidence interval for what? What is this? Mu of Y when X is 3. This is for mu hat of Y when X is 3. So you need to confidence. This word confidence is also, where is it? I did not give the word confidence. No, I did not use the word confidence. I used the word interval estimate so that it's not clear whether I'm asking for prediction interval or confidence interval. This one is about confidence interval. Just read the question 2 times and you will get to know. It is asking for the interval estimate for the average of Y, mu of Y, when X is 3. Lower limit, upper limit, interpretation. What is the interpretation? The average completion time of 3 invoices is between this and this. Correct. Is the prediction done in part E, interpolation or extrapolation? We did not cover this yet. Is it? We did cover it. Is it interpolation or extrapolation? How will you know it? You look at 3. If 3 is within the domain of available X, look at the available data. If 3 is within the domain for multivariate, we did not do it yet. Did we do it? For multiple regression, we did not do it yet, but for simple, it is simple. You just check the given value of X, which is 3. Does it fall within the domain of the available data? For example, I gave you the data on 26 invoices, and those 26 invoices are, let's say the data is from 5 to 39. So does this 3 fall within 5 to 39? No, this is extrapolation. If that is the case, if it falls within the data, it's interpolation. This one, computational.
Computation seems to be easy.
I don't know.
Unusual.
I don't
You
know.
like your system.
Both are easier. Both are easy.
Doesn't seem.
It doesn't seem easy.
No.
No, you should say it seems easy, but when I do, it's not easy. Okay, this question is about multiple regression. This says that download another data from Blackboard. This one is for question number 6, another data with different code, of course. This one will have a sample of 13 countries. And for those 13 countries, we have Y as the average January temperature. X1 is the latitude, X2 is the longitude, and X3 is the elevation of that place, that city, state. So you have the data on 13 states. You have X1, X2, X3, 3 predictors, and Y is the response variable. The data is given for that. What are you required to give? The beta hat vector. Here, I'm not forcing you in any way to use the X transpose X, X prime Y. You just go to the data analysis, find beta hat, and plug it in here. You will get the credit for the left side. For the right side, variance covariance matrix. This will be a 4x4 matrix, 16 values. Here you are forced to use the matrix approach because the data analysis tab will not print the covariances for you. It will print the variances, but it will not print the covariance between beta naught hat and beta 1 hat, beta naught hat and beta 2 hat, beta naught hat and beta 3 hat. It will not print the covariances. So you need to find MSE and multiply it by X prime X whole inverse to get the variance covariance matrix, which is a 4x4 matrix, and plug the answers in here. Clear? Yes, 16 values, whole matrix. Then it says there is another county, a new county. This is prediction, future prediction. There is a new county, Houston. Now for Houston, the longitude, latitude, and the elevation is given. X1 naught is 29 point something, X2 naught is 99 point something, X3 naught is 49. Predict the temperature of Houston. Also construct a 94% confidence interval. Is this prediction interval or confidence interval? How many states am I giving you? One state, it's a prediction interval. I'm giving you one state, Houston. I'm not asking you to take all the states with this longitude, this latitude, and this elevation, not all of them. One state, Houston, I'm talking about single state. So this is a prediction interval, 94% prediction interval. Where is the average? The variable is average high temperature. The variable itself is average high temperature. Don't confuse this average with that average. The name of the variable is average January high temperature. Okay, here you are no longer supposed to interpret. Give the point estimate, Y naught hat, give the lower limit, give the upper limit. That's it. 1 point, I think, for the point estimate, 2 for the lower limit, 2 for the upper limit. Nothing, no interpretation is required here. The interpretation is actually given in the question. And this is it. This is the exam. This was the exam. Let us have a look at another exam. 191. Again. Yeah, tomorrow we'll only do the computational. No. Look here, for the multiple linear regression model, Y equals X beta plus epsilon, derive the beta hat vector using the ordinary least square estimate for beta. Any confusion? You just need to derive beta hat using OLS estimation for multiple linear regression model. I think week 6. From the notes. Part B. Denote the residuals by E, which is y minus y hat. Show that X transpose E is equal to 0. And from there, you need to prove that sum of residuals is 0. This is an unseen question. We haven't done this one. It doesn't mean this is not covered. It is covered. I mean, this is an unseen question, a built-up question. This is one of the properties of OLS estimators, that summation X times E is what? It is 0. This is the same property in terms of multiple regression. Go and look for this one. Show that the predicted values are uncorrelated. From there, there is an assignment for part 1 is summation xi ei is 0. Part 2 is summation y hat ei is also 0. So the same pattern. The first part is summation xi ei is 0. The second is summation y hat ei is 0. So these are exactly the same pattern questions in multiple regression. Uncorrelated means that it's given. They are uncorrelated with the residual means that this is 0. You need to prove this.
Summation of this or
No, the thing. No covariance, no summation, just the product.
I think two variables or anything are unconnected to each other means that
In matrices, when you multiply this, it is like a summation. When you will multiply them, it will be like a summation. Question number 2. Look at the question. What are you supposed to prove? The unbiasedness of beta naught hat and beta 1 hat for the simple linear regression model. Lecture? Week 2, I think, or 1. Yeah, this is similar to. No, this is not similar. In that exam, I gave you that you can use the unbiasedness without proving it. Yeah, now in this exam, we are asking for the unbiasedness. Derive the expected value of beta naught, beta 1. Same question, exactly the same question, using the covariance. Here I gave them the hint while in the room. Is expected value of this equal to this? If yes, why? If no, why? Are they equal? But they are not independent. We proved that the covariance is not 0, which means they are not independent. So they are not equal. You will say they are not equal, and the reason is why there is linear dependence between the two of them. Now this is, I think, the computational, I guess. No, this is like a simple question of 211, 212. The sums are given. Yeah, don't expect something like this. I'll give you just the 2 columns. Don't expect me to give you x square, y square, and xy. You'll find it yourself. Construct and interpret a 95% confidence interval for rho. Which week? Let me show you. I'll show you where it is. Rho. Where is rho? Week 5? 5. Here it is. Where is the confidence interval? Here it is. Down? Yeah. Here is the confidence interval for rho. This is what you are supposed to do. You are supposed to find R and plug it into this thing. Fit a linear regression model to predict. So you are just supposed to fit the model and give the equation. Estimate the error variance. What is error variance? What is error variance? No, error variance is sigma square. And how do we estimate it? MSE. So you're supposed to give MSE in this question. Compute the coefficient of determination. What is coefficient of determination? R square, and interpret its value. What is the meaning of R square value? Percentage variation explained. Test the hypothesis that the regression line passes through the origin. What is this hypothesis? Beta naught equals 0 against not 0. This is what you are supposed to test. You will give H naught, H1, T value, P value, and decision. Using 1% significance level, find an interval estimate for the mean Y if X is 95. What is this? Mu hat, no, it's not the prediction interval. It says the mean of Y when X is 95. This is a 95%. This is the 99% confidence interval for the mean of Y mu hat when X is 95. This one was bonus. This one was bonus. Again, what are we supposed to do here? MLEs. I think we did not do MLEs this semester. Plus, you are free to go now. Tomorrow, I will see you guys. If 20 of you are there, I will see you at 3:30, inshallah. It's better that you get there by 3:15 so that you send me an email by 3:15 and I'm there in 10 minutes and we start by 3:30. I will start. If I'm told at 3:15, I will be there at 3:30.
I have a question.
Yeah.